Now we want to compare the graphs of each function with the graph of its parent. So in this case, we've got a parent function of f of x equals x squared. So we want to know what happens when we take g of x equals 4x squared. So basically the question is, what effect is this 4 having on the graph? Well, using what we just learned in our table, putting the 4 out there is going to result in a vertical stretch. Okay, so from our original function, if this is your original parabola, think about stretching it in the vertical direction, so it should get skinnier. Okay, now that's a really bad graph. We'll take a look at it on Desmos in just a second. Let's look at for b. H of x is 1/4 x squared. So what is the effect of multiplying by a fourth? Again, using what we just learned, since that factor, c, is in between 0 and 1, this is going to be a vertical shrink. Okay, so if your original parabola looks like this, that is really bad, think about shrinking it, so kind of smashing it down in the vertical direction. So it's going to kind of widen out. Now, that one particularly was hideous, so let's look at Desmos for these two. So here's our original parabola, y equals x squared, and we want y equals 4x squared, so there it is, that vertical stretch, and 1/4 x squared, here's that vertical shrink, so think about smashing it, and it's going to make it wider. Okay, so let's look at number 5. We have the graph of f of x equals x squared plus 3, so that's another parabola. We learned from the front side of these notes that the adding 3 just moves it up from where it was before. So already we have a parabola that's up 3, something like that. So now we want to know the effect of multiplying by 2 on the inside. So what we're really doing here is we're taking f of x, so this thing over here, and we're plugging in 2x. So we're taking 2x squared plus 3. So we want to know what's going to be the result in this. So using the table above, we can see that if we put the 2 on the inside of this, that's going to result in a horizontal shrink. Okay, so think of taking it in, like take the parabola in your left and right hand and shrinking it together, moving your hands together and smashing it in from the horizontal direction. Okay, so instead of having something like this, it's going to look like this. Okay, now technically this is also a vertical stretch, because if we simplify this thing right here, you remember this, we can distribute this. That's 4x squared plus 3. So that 4 was going to act kind of like the stretch. So that's why I said they were very similar. But for our purposes, we're going to stick with this one. Okay, last one. We want to know what's going to happen with f of 1/2 x. So we're taking the 1/2 x and plugging it in. So we want to know what is the effect of this graph. Okay, and we know from our table that this is going to result in a horizontal stretch. So take your original parabola and then think about grabbing onto it in your left and right hand and pulling your hands apart slightly. Okay, so this should widen it out a little bit. And again, those are really ugly graphs. Let's look at Desmos with these. So here's the original, x squared plus 3. When we plug in 2x for that, it should get skinnier, just like we said. That's that horizontal. And with the 1/2, it gets wider.